All right, 1.7, transformations of functions. Okay, now this is where graphing all different types of functions becomes very easy to do once you understand a couple simple principles. All right, starting off with the shifting rule. If the number is inside, then shift the starting point opposite horizontally. All right. And if the number is outside, then shift the starting point vertically. All right, so what exactly does that mean? Here's a couple examples. Check it out. So here I have the absolute value function, or absolute value of x. Now the starting point is always at the origin, and we know it's a V-shaped graph. You just go up one, right one for the slope, right? Okay. Should all be familiar with this at this point. Okay. But now you don't need a graphing calculator if you understand these principles. Here I have a -1 outside of the absolute value. And when it's outside, we shift vertically. All right, so I'm going to take the origin from the original parent function. Parent function is just the original function with nothing happening to it, just a simple absolute value of x. All right, I'm going to take that starting point and just shift it down 1. All right, and then you're essentially shifting all the other points down 1. All right, so you're just repeating the same pattern as before with the slope. Okay, and the whole graph has been shifted down 1. All right, so once again, number on the outside, shift up or down depending on what that value is. All right, here we have the value inside. All right, now you want to take the opposite approach from whatever this value is. It says add to, so you don't move to the right, you move to the left. All right, so here I'm going to take my starting point. I was originally at 0, 0, and I'm going to move it to the left 2 units. All right, and I'm going to do that with every other point. So here I am now with my little graph. All right, that's where it ends up. All right, and then combining the two ideas together, here I'm going to shift the starting point down 1. Here I'm going to shift it to the left 2 units. So left 2 units, down 1. Here I am for my starting point for the absolute value function. And then just applying the slope, up 1, right 1. Oops, it's a little off there. Okay, and that's the basic idea. Let's go on to another example. All right, now for the reflecting rule. All right, if there's a negative outside the function, then what you're going to do is reflect the graph over the horizontal line that passes through the starting point. Okay, so here's the parent function. All right, that's the parent function. All right, so what are you supposed to do? I'm supposed to reflect this graph. After I've done my shifting, then you do the reflecting. In this case, there's no shifting, but okay, here's the starting point, and I need to reflect the graph over the horizontal line that passes through the starting point. So it's going to reflect, and it's going to end up on this side. So the blue graph is the graph of this function here. All right, so here we had f of x equals the square root of x on top, and now here we have f of x equals the negative of the square root of x on the bottom. This is what we wanted. All right, going on to the negative being inside, then you will reflect over the vertical line that passes through the starting point. And once again, you reflect after you do your shifting. Okay. All right, so then once again, I have the parent function. All right, there it is. And now I have to reflect over the line, the vertical line that passes through the starting point. So it's going to end up on the left side then. All right. and there's my function if the negative's on the inside. That's all there is to it. So once again, first you do your shifting, then you do your reflecting. On to the next example. All right, so bringing all the ideas together now, you first shift, then you reflect. All right, so what's happening here? This is a quadratic function. That's going to be a parabola. And what do we have to do? All right. Well, this is a simple parabola here, right? That's what it's supposed to look like. Okay, so where am I going? Just needed the general idea. So I'm going to move the starting point up 3 and move it to the left 2. So up 3 to left 2. There's my starting point. There's no negatives involved here. So then there's my general graph. It's not that precise, but that's the general idea. You know where it starts. Okay, for the next one, I'm going to shift up 3 to left 2. All right, but now here I have a negative. All right, that's what it would look like without the negative. Now I have to run a line horizontally through the starting point. All right, so that's the negatives outside. And I have to reflect it over that line, and this is what I get for my graph. Looks something like that. All right, so that's the general graph. All right, now for the negative being inside. And notice that this negative was factored out from these two terms, and that's very important. Watch out for that. All right, so here I'm adding 3, and once again I'm going to the left 2. All right, this is my graph before the reflecting. Now, since the negative is in the inside of the square piece to the function, that means I have to reflect the graph over the vertical line that passes through the starting point. Okay, and in this case, you're just essentially twisting it around. How do I explain this well? Let's see here. This side twists over to the right. This side goes to the left. So you get essentially what you had before. All right, but depending on the graph, since this is a quadratic, yeah, it looks the same. But if you're working with other functions, for example, a cubic function, it's going to look very different. All right, but that's the general idea. First you shift, then you reflect. On to the next example. Okay, for these examples, I'll be choosing a couple x values. All right, so you could understand this concept of vertical stretch and vertical shrink. All right, so for the first graph, I have -2, -1, 0, 1, 2. All right, plugging those values in, I'll get 8, 2, 0, 2, 8. All right, plotting these points, here I am. All right, going up a little further, I'm up here. Okay, so what's going on here? This is known as a vertical stretch when you throw a number in front of the function like this. All right. So what do I mean by vertical stretch? It's as if you're grabbing on to both sides and you're pulling it up. And what it's essentially doing is it's narrowing, all right, the graph from the left and the right. So it's just stretching it out. All right, so when you throw a number in front and it's greater than 1, that's known as a vertical stretch to the graph. All right, now if the number is between 0 and 1, and you throw it in front, what happens to the graph then? I have -2, -1, 0, 1, 2. And you could also mess with these functions on your TI calculator to grasp the idea better. Just keep replacing the value in front with different values so you can see what effect it's having on the graph. So here I have 2, I have a half, 0, half, and 2. All right, so here I am. And then up to 2. All right, and there's my graph. All right, so this looks a little wider than the normal parent function. What's essentially happening, instead of pulling it that way, it's as if you're like pushing the graph down, right? And that has a widening effect on the graph. All right, so when the number in front is between 0 and 1, that's known as a vertical shrink to the graph. All right, now what happens if you throw the number inside of the function? Because here we have squared, and we're squaring everything. What effect does that have on the graph? We got 16, 4, 0, 4, 16. Okay, so here I have 0, 0, negative 1 up 4, 1 up 4, and I'm going way up. All right, so there's my graph. All right, and this is known as a horizontal shrink, because if you're looking at it from a horizontal perspective, what's happening horizontally to the graph? All right, the points are coming closer and closer together in comparison to the original graph. All right, so if you have the number inside being greater than 1, then it creates a horizontal shrink. And for the last one, we have negative 2, negative 1, 0, 1, 2. And you have 1, 1/4, 0, 1/4, and 1. All right, so I got 0, 0, 1 1/4, 1/4. Then I got 2, 1, negative 2, 1. All right, there's my function. All right, so what happens if the number that you throw in front, that's inside of the square, is between 0 and 1? That has a horizontal stretching effect. So looking at it from a horizontal perspective, all right, it's as if you're pulling the graph apart left and right, and it's having a widening effect on the graph. You're stretching it horizontally. All right. So this concept is not that difficult to grasp. I encourage you to punch in a bunch of graphs on your TI calculator and mess with this value in front, okay, and inside, and just keep manipulating it and changing it, and I'll give you a good idea of what effect these numbers have on the graph. All right, so if you have any questions, let me know. Also, make sure to study the 2 last pages to your yellow sheet so you can see how all the graphs relate, because once you understand how they all relate and you understand the general principles, it's really easy to graph any of these functions. All right, make sure to ask questions if you have any. Start working on the assignment at the bottom of the web page.